Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter Is Matter Pure? In this session, we are going to see a practice sheet related to this chapter. In the earlier sessions, we have studied about what is matter, how it is classified into pure and impure, and the different kinds of mixtures, and the different separation techniques used for the separation of these mixtures. We have seen these all. So based upon these all concepts, we are going to see a practice sheet now. Let us see first about single correct answer type questions. So here there will be a question with four options. Out of four, one will be correct answer as we know. So read the question and answers carefully and try to answer them. See the first question. The properties of mixture are dash to its components. So how the properties of mixture will be when compared to the properties of components? What happens when two or more components are mixed to form a mixture? They won't lose their properties, so they retain their properties. So that is why they can be separated by using some physical means. So the properties of a mixture will be almost similar to the properties of the components mixed in that. They won't change their properties. Next question: what is water is a compound because? Is it? Water is a called compound, isn't it? Yes, water is a compound and it comes under pure substances. Now, why it is called so as a pure compound? Because let us see options. Composition is fixed. Yes, if it is a mixture, the composition might be varied from one mixture to another mixture. But if you take any compound, its a chemical composition will be always the same and fixed. For example, if we take water itself, we know its molecular formula as H2O. That means in one molecule of water, there are two hydrogen atoms and one oxygen atom chemically combined. This composition is always, and wherever you take the water, it is fixed. However, you prepare water, when water is formed, with this combination only it will be formed. So, for a compound, the composition is always fixed. So for water also it is being fixed. Water comes under compound. So it is a correct statement. So the next statement, properties are different from its components. Yes, for compounds, the properties are being entirely different from the properties of the components combined chemically there. If we take in case of water itself, water is formed from two elements, hydrogen and oxygen. We know the properties of hydrogen. Hydrogen is a gaseous element and it is one of the lightest gases. It is lightest gas and it is highly explosive. It can burn in the presence of air with a blue flame. It causes blasting also. So explosive gas it is. And if you take oxygen, oxygen is also one of the gaseous substance which is essential for breathing and dissolve and is one of the mostly existing gas in the atmosphere after the nitrogen. So there are different properties of oxygens, oxygen and hydrogen. When these two combined chemically, they form water H2O. But the properties of water are being completely different from these two. Water is a liquid substance. It is non-combustible, non-supporter of combustion, and mostly used as a fire extinguisher, isn't it? These are the properties of water. So the properties of chemical compounds formed will be entirely different from the properties of the components combined. So second statement is also true about water, to say as it is a compound. Next one, components can be separated by chemical methods. By only chemical methods. Yes. Suppose here if you say water itself, water is formed from hydrogen and oxygen. These hydrogen and oxygen cannot be separated by using any physical method. These can be separated only by chemical means, chemical techniques only. For example, by passing electricity through this water by adding some acid to that or acidilated water. Then only water molecule will be split into hydrogen and oxygen gases. Otherwise, in any other physical methods, we cannot separate this compound. So generally, compounds cannot be separated by using physical techniques like filtration or some other sedimentation. These all we cannot use this. We cannot separate these compounds by using those. Only the compounds can be separated into the respective components only by chemical methods. So water also in the same way it cannot be separated by physical means and it can be only separated by chemical means. So this also proves as water a compound, chemical compound. So these are the three correct statements which are supporting to say as water is a compound. Now the correct answer will be all of these. Next one, which of the following is a colloid? Say paint, blood, milk, these all will come under colloids. These all are colloidal solutions. Which of the following will show Tyndall effect? What is the Tyndall effect? When a light is passed through a solution, then the particles present in the solution will scatter the light. So that seems like glowing. That property is called Tyndall effect. So which of these can show the Tyndall effect here? So the solution or mixture in which there are some particles this considerable size, they can show this Tyndall effect. Out of these given here, if we observe salt solution, will be the particles visible? No. When salt dissolved into water, that dissolves into water. That disappears actually to say it forms a clear solution. Even vinegar solution also, when acetic acid is dissolved into water, it forms vinegar. So there is no visible boundaries for these particles after the mixing. Even sulfur in water also. Actually, sulfur won't dissolve into water, it settles down. But whereas in milk, fat particles are spread over in the water with considerable small size. So when light is passed through this milk, these fat particles will scatter the light. So that is called showing Tyndall effect. So milk can show Tyndall effect because of the presence of fat particles in the water. Okay, next one. The process of separation of insoluble solids from a liquid is called. Yes, separation of insoluble solid from a liquid. How can we separate a solid from liquid? Generally, different techniques can be used. One of them is filtration. If the solid is insoluble into liquid, then if we pass this mixture through a filter paper by using funnel, the liquid will come down and will be collected in the other container in the form of filtrate. That insoluble solid substance will be remained in the filter paper that we call as residue. In that way, insoluble solid substance can be separated from the liquid by using filtration process. One more is a decantation also. There what they do, they will generally allow this mixture of a solid, insoluble solid in the liquid for some time. Then it will settle down. So after settling down, slowly they pass this upper layers of this pure liquid into another container that is called decantation. They separate liquid from the solid in that. But here they're asking clearly the separation of insoluble solid from a liquid. That is most appropriate one here is filtration. By filtration process, you can separate this insoluble solid substance. Okay, filtration. The process used to separate oil and water. What kind of mixture is this? Oil and water. We know both are liquids, but oil won't be dissolved into water. This kind of mixtures are called immiscible liquids. The mixture of two liquids which are not dissolving into one another is called immiscible liquids solution mixture. So such kind of mixtures, generally if you take oil and water in a container, one of the components will go down which is denser and the lighter density liquid will float on the other one. So in that way they form two separate layers. Such kind of liquid mixture can be separated by using a container called separating funnel. So, two immiscible liquids can be separated by using a separating funnel. Next one, what kind of solution is milk? What kind of solution is this? Just now we have seen the previous questions. It's a colloid. So this can show Tyndall effect. Milk is a colloidal solution. Next, a liquid and a solid are found together in a single phase. What is this known as? What they are telling here, they exist in the single phase, means in the same state. For example, if we take salt into water, actually salt is a solid substance. When you dissolve this common salt into water after stirring, we observe completely the mixture formed in the liquid state only. No solid is appeared or no solid is seen after mixing. So, solid and liquid substances are mixed. Finally, they came to one state, that is a liquid phase. Then that is called a solution or true solution. The mixture in which the components came into the single phase is called a true solution or solution to say simply. So here they're telling solid and liquid they came to single phase, then that is said to be a solution. Okay, next. Which of the following is a homogeneous solution? What does it mean homogeneous solution? Here this also can be given the same in the same phase. The mixture in which components are mixed uniformly and they came to single phase is called homogeneous solution. See here muddy water. In that mud particles will be seen through the water. So it is not single phase or homogeneous. If you see bread, it is also it is a, just we can say compound there. And concrete, if you see concrete, it is a mixture of what we can say sand, cement, and some gravel, water. These all are mixed. Even after mixing, also these sand and even these stone particles will be seen. So it won't come under homogeneous. Now, if you see a solution of sugar in water, what happens when you dissolve sugar into water? It completely dissolves into, it disappears into the water. It takes the spaces present between the molecules of water. So it will come to a single phase. It seems like a liquid. No solid particles of sugar will be appeared. So it can be said a homogeneous solution. The mixture of sugar and water is an example of homogeneous solution. Okay, next one. What kind of colloidal solution is an emulsion? So what is emulsion here? Emulsion is a mixture formed by mixing two immiscible liquids. So an immiscible liquid will be dispersed into another liquid. That is called emulsion. Now we can say emulsion is a colloidal solution formed when a liquid dispersed in another liquid. Okay, liquid in a liquid colloidal solutions are called emulsions. These we can say how face creams and these Vaseline are examples for these emulsions. Okay, next. What kind of solution is drinking soda or soft drink? We can say drinking soda. How do they prepare this drinking soda? So they take some water into a container first, and then by applying high pressure, they mix some carbon dioxide gas into this water. At high pressure, we know as pressure increases, solubility of gases into liquids increases. So by applying high pressure on this liquid and carbon dioxide gas will be dissolved into it. Now soda will be formed. So we can say soda is a gas in liquid mixture. Carbon dioxide gas is dissolved into water. Gas in liquid mixture it is. Okay. Next, what kind of solution is amalgam? Yes, amalgams are also mixtures. Actually, these come under metal mixture actually, but in this, one of the metals will be mercury. When metals are dissolved into mercury, they form amalgams. They form a homogeneous mixture called amalgam. For example, if gold is dissolved into mercury, gold metal will be dissolved into mercury and forms a homogeneous solution that is called gold amalgam. If a silver is dissolved into mercury, that forms amalgam called silver amalgam. Generally, these amalgams are mixtures of mercury with some other metals. So we can say metals in mercury or some solids into mercury. Okay, generally these amalgams like silver amalgam, mercury, silver, gold amalgam, these are used in filling of teeth cavities. So these amalgams are formed by mixing some solid metals into mercury. So solid in mercury. Amalgam is a type of mixture of solid in mercury. Okay. Next one. Which of the following operators is used to separate a mixture of immiscible liquids? What does it mean by immiscible liquids? Immiscible liquids means the mixture of two liquids which they do not dissolve one into another, which they do not mix each other. Such kind of mixture is called immiscible liquids mixture. For example, if you take oil and water or kerosene oil and water, when you take the mixture of these two, even though you stir them well, they won't mix one into another. They form two separate layers. The heavy liquid water will go down and the lighter liquid oil or kerosene oil will float on the water. So such kind of liquids are called immiscible liquids. These liquid mixture can be separated by using a funnel called separating funnel. Okay, by using separating funnel, two immiscible liquids can be separated. Next one, the materials which contains at least two pure substances and show the properties of their constituents is called. Yes, when two or more pure substances combine together and forming a matter which show the properties of the constituents mixed in it is called a mixture. So it's called a mixture. Next one. What is a solution of iodine in carbon tetrachloride called? Carbon tetrachloride. Actually, iodine is soluble in some solutions like some liquids like alcohols and one of the organic substance carbon tetrachloride. So actually the solutions can be liquid solutions can be classified in two types: aqueous solutions or non-aqueous solutions. Here aqua represents water. Aqua nothing but water. Aqueous solutions means the solutions in which the solvent is water. So some solid substances will be dissolved in water, then the solution formed are called aqueous solutions. If I say aqueous hydrochloric acid, that means hydrochloric acid is dissolved into water. So that water solution of hydrochloric acid is called aqueous solution. Aqueous solution means the solution in which the solvent is water. Some other solutions will be there in which water is not present. Even though they don't have water, some liquid will be there that dissolves some other solid substances into it. Such kind of liquids in which there is no water are called non-aqueous solutions. Means there is no water in that solution. So here if you see iodine dissolved into carbon tetrachloride and forming solution. But here it is a solution which does not contain water. Now we can say it is a non-aqueous solution. And even this iodine often dissolves into alcohol. Then also it is called non-aqueous solution and it is also called tincture of iodine. But here the solvent given is carbon tetrachloride. then it is simply called non-aqueous solution. Okay, next one. Which of the following is a characteristic of both mixtures and compounds? See, one of the properties is being common for mixtures and compounds. Let us see that they contain components fixed in fixed proportions. Of course, compounds are having the components fixed proportion, but mixtures they do not. The composition or the proportions of the components may vary in the mixtures. If we take 1 glass of water with 1 spoon of salt, that is a mixture. So the same 1 glass of water, you can add 2 spoons of salt, then also it is a mixture. So the proportions of the components in mixtures may vary, but in compounds does not. It is fixed composition in compounds. So it is not common property. See the next one. Their properties are the same as those of their components. Yes, in mixtures, the properties are similar to the properties of the components, because after forming mixture also properties of the components won't be changed. They retain their properties. But in the case of compounds, properties will be entirely different. They change their properties. So it is also a not common property. Next, see, their weight is equal to the sum of the weights of the components. Yes, this is correct, and this is a common property of mixtures and compounds. The total mass of the mixture or compound formed will be equal to the total mass of the components mixed or combined to form these mixtures and components or compounds. So this is according to law of conservation of mass. The total mass of the components in the mixture or compound will be equal to the total mass of the mixture or compound formed. Mass won't be changed. Okay, so this is a common property of mixtures and compounds. We can say this. Okay, next question. Which of the following is an example of a mixture? See here, out of the given, which is a mixture? See the first one, sugar. Sugar is not a mixture; it is a pure substance. It is a single kind of molecules represent in that. So it is a pure substance that is called compound. What about next one? Brass. We know brass is an alloy. What is an alloy? Alloy is a mixture formed by mixing two or more metals with a carbon. Then the resultant mixture formed is called an alloy. So alloy is a mixture of two or more metals. So brass is a mixture. Generally, brass is made from copper and zinc by mixing these two metals in the molten state. So a mixture is formed brass. Okay. Now carbon dioxide and nitrogen dioxide. These two are also will come are coming under pure substances, and that too they are compounds. Next, by which process the drugs from the blood are separated? Generally, the drugs present in the blood can be separated by using some techniques like chromatography. In chromatography, the small particles present in the mixture also can be separated. So chromatography is used for separation of drugs from the blood samples. Okay, next. Which of the following processes of separating substances involves both evaporation and condensation? Yes, evaporation means the conversion of a liquid into gaseous form, and condensation means the conversion of vapors of liquid into liquid form again on cooling. So in which process these two are occurring simultaneously? See here, filtration. Will be there any change in the state? No. Just an insoluble solid will be separated from the liquid component in the filtration. So it is not. What is crystallization? Crystallization involves Separation of the dissolved solid substance from the liquid into the solid form again. If you see distillation, in distillation process, what happens? The mixture of an insoluble solid from the liquid can be separated. They do first their evaporation process. Then the liquid component will be evaporated into the gaseous form. Solid substance will be remain back. And these vapors of the liquid obtained here will be collected and cooled again. Then they will condense again to the liquid form. In that way, the mixture of solid and liquid will be separated by using these two techniques called evaporation and condensation. These two will be done in this distillation process. So distillation involves these two, evaporation and condensation. Okay, next one. Which of the following processes is useful to collect pure water from a solution of sugar and water or salt and water? Yes, which process can be used for the separation of salt and water or sugar and water? We can use either distillation or evaporation. In the evaporation process also, water will be evaporated off, pure salt or sugar will be remained up. Even the distillation also, water and salt or water and sugar can be separated. But if you observe once the question clearly here, to collect pure water. So to collect the liquid component, compulsory you have to follow distillation process. Because in the evaporation process, sugar or salt will be remain. Water will be evaporated off. It cannot be collected in that process. So to get back the pure water, we have to collect those vapors and we have to condense them. This happens only in the distillation process. Next one. Which of the following processes can be useful in separating the salt from a mixture of sand and salt? So what to be separated? Salt to be collected. So we have to collect the salt and we have to separate sand from it. So how can we separate salt from the sand? Can we do by filtration or evaporation? We cannot. So the only technique used here it is dissolution process. So out of this sand and salt, we know salt is soluble into water. If we pour water into this mixture, salt will be dissolved into water, whereas sand remains undissolved. So when you take this to filtration, sand can be separated from this mixture. Now salt water will be separated. From that, salt can be separated by using evaporation later, evaporation or distillation. So here, the technique used for the separation of salt from sand is dissolution, dissolving the mixture into a suitable solvent. Next, by which method can ammonium chloride be separated from sand? Ammonium chloride. It is one of the components which can be converted into gases formed directly from solid state on heating, isn't it? It won't be. It will be converted from gas to solid to gas on heating. That's called sublimation. So ammonium chloride is one of the sublimable substance. This can be separated from sand by the process called sublimation. Next, what is the technique used to separate dirt particles from clothes in a washing machine? Yes, dirt particles are removed from the clothes in the washing machine by whirling, twisting or rotating fastly. That is called centrifugation. By centrifugation process, dirt particles are separated from the cloth. What type of mixture is steel? We know steel is a mixture of solid components. Generally, iron is mixed with some other metals like nickel, chromium, and some carbon. These all are mixed. So, their solid homogeneous mixture is formed in the formation of steel. So, steel is a solid homogeneous mixture. Next question. Identify a pure substance from the following. See, pure substance. The first one say here, steel. Is steel a pure substance? No, because just now we have told steel is a mixture of two or more solids, two or more metals. So steel is not a pure substance, it is a mixture. And if you see next one, magnolium. It is also one of the alloys just like steel, but the components are different. Two or more metals are mixed in this also. So magnolium is also one of the alloys and it is a mixture, not pure substance. And what about ammonia? Ammonia is a chemical compound with molecular formula NH3. It has fixed composition. So ammonia is a pure substance and it is a compound. Ammonia is pure substance. What about gunpowder? Gunpowder is a mixture of sulfur, charcoal, and dissolve. These all are mixed up in the formation of gunpowder. So it is a mixture, not a pure substance. Only ammonia is a pure substance among these all. So they are the single correct answer questions from this chapter. Is matter pure? Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.